All right, so this is going to be our last lesson before your test tomorrow, and this will be on your test tomorrow. Okay, everybody has their hand out in front of them. We're ready to go? Okay, so let's start with a warm-up. I want to know whether or not the following ordered pairs are solutions to the inequality. How do I check to see if something is in fact a solution without a number line here? Because normally we'd have a number line and it'd be shaded, yes? Well, I don't have that, do I? And this time I have an X and a Y. You guys see how they're ordered pairs? So what am I going to do to see if they're solutions or not? How do you check if the solution is true or not? Plug it in, right? Okay, so everybody agrees this is the X, this is the Y, yes? Look at your inequality. Is there even a Y in there? No, so am I going to be plugging in a Y? No, so here we go. I have 2 is greater than or equal to 2. Is that true or false? True. So that one's a good solution. Second order pair there. I'm going to plug in -2. True or false? So that one is not a solution. And third ordered pair. I'm plugging in 0. Is that true or false? False. So of those 3, only one of them are solutions. How we doing? Okay, let's move over here. This time I do have an X and a Y. So if I'm going to plug that first ordered pair in, it's going to be 1 minus 3 times -1 is greater than or equal to -2. Folks, what do you get on the left-hand side when you do 1 minus 3 times -1? Positive what? Should be positive 4. Isn't -3 times -1 a positive 3? So that's 1 plus 3, which is... Type it in your calculator, folks, if you don't trust yourself. Okay, true or false? That's true, isn't it? Okay, second ordered pair. What do I get on the left-hand side here? -4. Is this true or false? That is false. -4 is not greater than -2. And finally, we're going to put in 0, 0. What do you get on the left-hand side here? 0. So is that true or false? True. Okay, so those two are solutions. Yes, sir. It isn't 1 minus 3, though, because this negative times that negative makes a positive. So there is no more negative left. It's just 1 plus 3. Okay? So, folks, as you can see on the bottom here, we're going to be actually graphing these on a coordinate plane now, aren't we? Before we graph them on a what? Number line. Because how many variables were in them? 1. Everything was X's, or everything was A's, or everything was B's, yes? Look at your examples today. They could have X's or Y's, correct? Which means it's got to go on a coordinate plane. Fair enough? Okay, so graphing linear equations in 2 variables. You guys see how I have that 2 capitalized? Yes? You are going to include the boundary line if there is an equals bar. That means you're going to make it solid. So remember how we had closed circles on the number line when we had the equals bar? In order to show that on a graph, you're going to make your line solid. Okay? So do not include the boundary line if there is not an equals bar. And instead of solid, we're going to make it dashed. So remember how we had an open circle when there was no equals bar? In order to show that on a graph, we're going to make our line dashed. Sometimes I call it dotted. Okay, it all means the same thing. So if you've got a straight edge, I would take that out because we are going to use them. We are going to be making lots and lots of lines here. You see a picture there. If you need a ruler, you can come on over and get a ruler. Does everybody see that picture there? I know yours is not blue and green like mine is, right? Okay, does everybody see the boundary line? That's the equation that you're going to graph. And folks, what form do I want equations to be in if I'm going to put them on a coordinate plane? Slope-intercept form. It's got to be in y equals mx plus b. So I'll remember that? Yes? So that line will either be solid or dashed, depending on if it's an equals bar or a not equals bar. Then, do you see where it's designated a half plane? You either are going to have to shade the upper half plane or the lower half plane. We're going to shade above the line or the upper half plane if it's greater than, because doesn't greater mean above? And we'll shade below or the lower half plane if it is less than, because that would mean smaller than. Is that making sense to everybody? Yeah? Okay, best way to do this is to go ahead and do them. All right, graph each inequality. So first and foremost, do you see number 1 there? The y is all by itself already, which is great, but there's no x's. So if there's no x's, it can't what? Cross the x-axis. How do I never cross the x-axis? Horizontal line starting at y is 4. So I'm going to put a little point at y is 4. Now, before I draw my horizontal line, I need to know if that's going to be solid or dashed. It's going to be solid. Does everybody see the equals bar underneath that greater than symbol? So this is going to be a solid line. And is that a greater than or a less than sign? Greater than, which means I'm going to shade which one, the upper half plane or the lower half plane? Upper. So this is where my shading would be. So can you all tell me an ordered pair that would be a solution to this inequality? 0, 7, you say. Is that in the shading? Yes, it is. So that would be a solution. 4, 6. What do you guys think? Sound good? How about -3, 4? Because the line is solid. Are we clear on that? If it was dashed, would I be able to include that point? No. All right, let's try another one. Number 2, there's no y, so I can't isolate the y. So what's that mean? It's going to be a vertical line because if there's no y, it can never cross the y, yes? So we're going to start at x is 1, which would be right here. Now, before I draw my line, I need to know if it's dashed or solid. It's dashed because there's no equals bar on that thing. Now, is that a greater than symbol or a less than symbol? Less than. Now, I don't have an upper and a lower half plane, do I? But I need to know, is less than to the left or to the right? To the left. So I will shade to the left of that boundary line. Can you all give me a point that would be a solution here? -1, 0. What do you guys think? Looks good, right? Give me another one. -3, 4, right up here. How about that guy right here? No, because it is not solid, right? So I do not get to include it. Doing okay? Yes? All right, let's take a look at number 3. Number 3 says x is greater than 0. Now, folks, typically, if there's no y, it can't cross the y, can it? But folks, isn't x equals 0 right on the y? So you need to know, is x equals a number vertical or horizontal? It's vertical. So I'm going to draw a vertical line. And yes, I know it's going to be right on the y-axis and it's not supposed to cross, but this is a special case because we're using 0. Does everybody understand that okay? Solid or dashed for this line? Dashed. That says greater than 0. Should I shade to the left or to the right of that? To the right. Hey folks, is 0, 0 a solution? It is not because that line is dashed. It is not included. How are we doing so far? Good? Okay, number 4 there. What do you think? I got no x's. It's going to be horizontal. Starting at y is -1. Will that line be solid or dashed? It will be solid this time. What symbol is that up there? Less than or equal to. Does that mean above or below? below. How about 0, 0? Is 0, 0 a solution this time? What do you think? 0, 0? No way. 0, 0 is not even in the shading, is it? Okay, so those are all the special ones, the horizontal and the vertical ones. Let's get to some regular old lines here. Remember, I got to have the y be isolated. Is that y isolated? Perfect. So where am I going to begin? On the y-axis. Remember, this is your y-intercept. And what's my slope? 1 over 1, which means I'm going to go where? Which way over? To the right. Now, folks, do you remember how I told you? I think I told you had to have 5 points before. Did I tell you guys that or no? Yeah, 5, 3. I told you didn't need that many, didn't I? But folks, don't I have to shade here? You need to extend this line as far as you can go so your shading is accurate. If I just stop here, my shading in this area is going to be pretty sketchy, isn't it? Because I'm not going to have a line to butt up to. So you have to take those dots all the way out to the edge. So you know exactly where you're shading and where you're not shading. Before I do that shading, is this line going to be solid or dashed? It will be dashed. And what kind of symbol do you have in there? So we will shade, no. That means above or below. Below. The only time we do left and right, guys, is when we have those vertical lines. Does that make sense? Yeah. Everything else we can just do above and below, but the vertical lines are a little bit different. How about 0, 0? Is it a solution this time? Is 0, 0 in the shading? Yes, it is. So it is a solution. So if I plug in 0, 0, it's going to make it what? True. It's going to make it correct or true. All right, number 6. What do you guys think? Is the y by itself? It is, but I'm just going to flip it around so I get that in y equals mx plus b form. Where do I begin? What is the y-intercept? 3 on the y-axis. It's the y-intercept. What's my slope? Where do I go? So down 1 to the right 1. Remember, we always run to the right. And you guys will come to hate slopes of 1 because you got to put so many stinking points on there. Solid or dashed? Solid. What symbol is up there? Less than or equal to. So does that mean above or below? Below? How we doing, guys? Bad? Now remember, if it's a negative slope, it's got to go down, doesn't it? Yeah. What's up? I got to be able to tell. You better make it dashed enough that I can tell it's dashed. Okay, so a question like this, if you don't have to isolate the y, it's only worth 2 points. You get 1 point for your line, 1 point for your shading. Like in the next one, how you have to isolate your y, it's going to be 1 point to isolate the y, 1 point for the line, 1 point for the shading. Fair enough? Speaking of which, how do I isolate that y? Okay, so what's my new inequality? Wonderful. Where do I begin this line? On the y-axis. Can I go down 1, right 1? Nope, so where do I got to go? Up 1, left 1, and it's going to cut off this little triangle here in the corner. Solid or dashed for this line? Dashed. Okay. And that's a greater than symbol. So should I shade above or below? Above. So that's all of this up there. How we doing, folks? The only thing that's different than regular graphing is just the shading, yes? Because that's the only thing that's different than a regular equation. Instead of an equal sign, it's a greater than sign. All right, when you're ready, go ahead and flip it over. And these are just going to require us a little bit more work in order to isolate the y. So how will I isolate the y in number 8 there? Minus the 2x. What's the new inequality? Good. Everybody notice how there's still a negative in front of that 6, right? Okay, now how do I isolate it? Uh-oh, you just said divide by negative, didn't you? So what does that mean I need to do? Flip that symbol over. Now, negative 2 over negative 6. A negative over negative is a positive. What is 2 over 6? Okay, so I have 1/3 x. And how about negative 12 divided by negative 6? Positive 2. So where do I begin? On the y-axis. What's my slope? Where do I go? Okay, so not as many points this time. Remember, then we go down 1 and back 3. Solid or dashed? Solid this time. Are we going to shade above or below? That's a greater than symbol, so we're going to shade above. If you're somebody that likes to use highlighters and colors, this is a good time to use it for the shading. Colored pencils, whatever you prefer here. But your regular pencil is fine as well, okay? Just don't make it super dark so I get it all over my hand when I grade your paper. Fair enough? You guys know what I'm talking about? Yeah. Number 9, how do I isolate that y? Well, that only took one step. That was pretty easy, right? All right, you guys go ahead. You graph it, make your line, and then shade it. Can you all tell which part is above and which part is below? It's pretty steep, right? This side over here would be above the line. Okay, when it starts to get steep, sometimes students have a little bit of an issue deciding where is above and where is below. How we doing? Any issues for me? No? You sure? Okay, you isolate the y in number 10 then. Get that y alone. Hopefully, you're getting negative 3 over 2 for your slope. And hopefully, you're getting minus 4 for your y-intercept. Yes, sir? I did not flip the symbol. You are correct because I divided by a negative 2. So that symbol has got to go the other way. How we doing? Fine? Okay, we're starting at negative 4. We're going down 3 to the right 2. Solid or dash this time? And are we going to shade above or below that? That is a less than symbol. Should be below. Is 0, 0 a solution? It is not. Okay, I feel like I'm kind of rolling through this. Is everybody keeping up with the pace okay? We're good? All right, 2 more of these before we go on to word problems down there. Take a look at number 11. Do you have that y isolated? You don't. How are you going to get it isolated? Subtract the 7x. Do you notice how there's already an x on the other side so it can combine with that x? Yes? Okay, now I want you to stop here because sometimes people ask me, well, aren't you supposed to move the smaller variable? Well, typically the answer is yes, but that's only when there's all x's, right? Here we're trying to isolate the y, so we want to get everything away from the y, and that's why we're going to move the 7x. So I get 4y is less than or equal to, that'll be negative 6x, and then minus 8. Now we'll divide by that 4, and I do not need to flip the symbol because I divided by a positive. Folks, what does 6 over 4 reduce to? 3 over 2. Don't forget that it's still negative. And then we'll have a minus 2 on the end. All right, so go ahead and graph that thing. Start at your y-intercept and then use your slope. Solid or dashed? Shading above or below? Below. And you know what? This brings up a very good point. I want everybody to take a look at number 11 that you just did. Does everybody see it? Yes? Take a look at number 10, the one right before it. What do you notice about those lines, number 11 and number 10? They're the same slope, aren't they? Which means if they were on the same graph, what would you tell me they are? Parallel, because they never what? Cross. So all you basketball players, do you know what parallel lines are? Yeah? Do you know what perpendicular lines are? Do you? Yeah, but you're making me look bad. Because your basketball coach was like, hey, what's up with these 8th graders not knowing what parallel and perpendicular are? So you better tell him that we cleared that up today, okay? Oh, I don't know about that. But you better tell him we cleared that up today, okay? Fair enough? Good? Okay. All right. What am I going to do here in number 12? What do you guys think? Distribute. I got connections, kids. All right, now I got to isolate that y, so what am I going to do next? Subtract the 4x over. So now I have negative 4y is greater than negative x plus 2. Now we'll divide by that negative 4, which means I've got to flip that symbol. I've got y is less than. That'll be a positive 1/4. Does everybody see why it's positive? And then what's 2 over 4? That'll be negative 1/2. So guys, where am I going to start? Yeah, I'm going to be in betweener, aren't I? Negative 1/2 would be down here, which means all of the rest of my points better be in between, right? Where am I going from here? Up 1 over 4, and again, I'm in between. Solid or dashed? Dashed. Above or below? Oh, I've got below. Do you all have below? Do you or not? Because didn't we have to flip our symbol? Yeah. Ooh, so this is a close one. Is 0, 0 a solution? It is not. All right, let's do some real world problems now. Financial literacy. The surf shop has a weekly overhead of $2,300. Guys, what's overhead? What does that mean? What does that mean? I can't hear you. Nope, it's not $23 profit. Nope, nope. That's what it costs them just to have the shop running. So they have to make another $2,300 to break even. So maybe they got to pay for their electricity, they got to pay for their employees to work. So that's what overhead is. It's like upfront cost. Does that make sense? We're getting there. Hold on a second. Write an inequality to represent the number of skim boards and long boards the shop sells each week to make a profit. Folks, if I want to make a profit, do I need to bring in over 2,300 or less than 2,300? Over. So that would be greater than or equal. Well, not equal to if I want a profit. Got to be greater than 2,300 bucks. Does that make sense? Okay, how am I going to bring in money? Well, I'm going to sell skim boards and long boards. How much does a skim board cost? 115. Did they tell me a variable to use? No, so we'll just use X. How much are long boards? Yikes. We'll call those Y. Now, if I would have told you a variable to use, then you would have obviously put those variables in there. There's my inequality. Fair enough? Okay, it says how many skim boards and long boards must the shop sell each week to make a profit? Now, folks, how many answers are there for this? Infinite, right? Can you find me one by guessing and checking? Go for it. Take a guess and check it. See if your number is greater than $2,300. It's going to have to be two separate numbers because we have an X and a Y. But you're not going to put them in an ordered pair because it's a real life problem. Only if I ask you to graph it would you do that. So does somebody find one that'll work? What do you got, Ashley? And how many? 2 skim boards. How would I check to see if she is correct? Plug it in. So let's do that. The long boards are the Y, right? So 685 times 3. And then the skim boards were the X. So can you type that into your calculator for me? What does that give you? I really can't hear you. $2,285, like that? Is that greater than 2,300? You're real close, Ashley. So I basically just got to buy one more of something, don't I? Well, actually, yeah, I only need to make another 15 bucks, don't I? Which one you want to buy one more of? The skim board, so we'll make this 3, which will change this to a 3. So then, what does that make my number on the left then? So if they sell 3 of each, they're now making a profit. Now, it's not a very big profit, is it? No. But they're still making some money. Fair enough? Yep, you just guess and check. If you had a graph, then you'd be able to look at the graph and see where the shading is, but you don't have a graph. And quite honestly, you don't want to graph things with 685 and 2,300 in them, do you? Didn't think so. All right, let's do this last one here. We're talking about modeling this question. It's not like modeling like a clothes model, okay? We're just modeling the situation. Sabrina is decorating her bedroom. She has $300 to spend on paint and bed linens. Does that mean I want to spend over it or under it? Under it. Could be equal to, though, right? A gallon of paint costs 14, while a set of bed linens costs 60. Write an inequality for the situation. So what do you think? Okay. Then it says, how many gallons of paint and bed linen sets can Sabrina buy and stay within her budget? 1 of each? 1 paint, 1 bed linen. So that'd be 14 times 1 plus 60 times 1. What does that give you? Does that work? Is that the only answer? No. That's called staying in a budget. Now she's got some extra money to do whatever she wants with, right? She could buy 3 of each? Yeah, there's tons of answers here. But folks, something you can't tell me is that she buys half a bed linen. Right? Could she buy half a gallon of paint? For sure. You can buy. Okay. Everybody good? So all 20 of you could have different answers for that, okay? All right, so for your homework, I have a worksheet for you, okay? Your test is tomorrow. Good? Any questions for me? Because I won't be here tomorrow. Yes. Correct. It's practice. It's not due tomorrow, but it's practice because will it be on your test? Yes.